just make sure that I'm on the screen. Yeah, yeah, we're gonna move it.
Hi,
Hello.
everyone.
Hello, Nadav. Good morning.
Good morning. Let me share my screen and we could just hop in. I know it's been a hectic day and 2 days for you.
Great. Thank
Here.
you. So we have 6 minutes, and then we're gonna have 6 minutes Q&A. Okay. Good.
Perfect.
Thank you.
Thank you. Hi, everyone. Let me see that the timer starts. Oh, okay. Never mind. Hi, everyone. My name is Nadav Manter. I am Director of Business Development at Ecojoule Energy. As most of you may know, the electrical grid can be analogous to a tree, where the roots are the power plants, the transmission line is the trunk, and the last mile distribution are the branches to the leaves, which are our customers. So is a traditional electricity grid. It's structured, it makes sense. Everyone knows where it's going to go. Even though it's complicated, it's beautiful. Adding renewables to the system is like adding vines to a tree. Either the vines will suffocate the tree or they will live in symbiosis. Currently, as of today, the vines are going to break the tree. As we see in Australia, this is a capacity map. Australia's grid is completely saturated. There are grids where they can't even add any more PVs to them or EVs. And this will be going on in the rest of the world as well. At Ecojoule, we create symbiotic products. These products can integrate renewables easily and cheaply into the grid. Our first product is the EcoVar. It's a power electronic system that uses reactive power to stabilize the voltage in the low voltage grid, as we can see in the graph in the middle. This is an example of a real life use case where we set, using only the EcoVar, of constant voltage. And when the EcoVar is absent, there are sag swells and phase imbalances on high penetration PV penetration grids. Our EcoStore system, it incorporates that EcoVar with batteries and active power. By adding that active power, we could actually add capacity to the grid, and it could act as a non-wire alternative with active grid support. We have over 100 units deployed internationally and over 60 EcoStore units sold already. We are finalists in Energy Lab in Australia, Energy Tech Summit in Poland, Israel, and we also just won a grant from the Israeli Energy Ministry. What we are offering today is a European project. And although it is a European project, we are open globally and thinking about a global presence. But currently today, what we're offering is a European project. The project consists of 10 eco stores placed in poor quality, low voltage grids. And since before the meter batteries have multiple value stacks and multiple business models, what we are offering is to test them all individually and in unison, along with a non-wire alternative. What we can see here is a drawing of where the eco store will be placed on the low voltage grid next to your customers. So pilot length will be between 18 and 24 months, costing around 650,000 euros, with an ROI between 3 and 6 years. Now, we know the regulatory system in Europe is constrained today, but what we're offering is the future. It's front of the meter batteries are the most scalable way to integrate renewables in the low voltage grid. And ahead in March, we're going to see a different regulatory world in Europe. And we are offering a pilot, a co-ownership pilot that might fit any different regulatory need. We will be operating the storage with hierarchies and different algorithms that will be based on a co-ownership pilot between different stakeholders, not just also aggregators and the customers themselves. We are looking for a win-win situation where we could implement storage and the DSOs don't need to update their grids anymore. Our team is adequately based to move this transition along. We have 2 teams in Australia and in Israel, with 15 full-time engineers working hard to facilitate any special need as we are a startup. We have decades in utility and energy experience along different value streams in the energy world and the grid world. And we have had multiple projects all across the world. We are looking forward to working with you. I try to keep it short and sweet because you have a very long day. Thank you for your time. And I hope that we could work together to change the way the electrical grid works. Thank you.
Okay, thank you, Nadav. So Q&A, please.
Good morning, Sylvain Labonté from Hydro-Québec. Is your technology patented or protected somehow, the IP?
Our power electronic system, which is the core of our systems, is patent protected, yes.
Okay, and thank you. And it can be remotely controlled. What protocol are you using?
Eshel, do you want to answer that?
Hi everyone, this is Eshel the Chief Business Development of Ecojoule. I basically did everything the Free Electron team not to do, but I'm currently in Bahrain on the move in an oil and gas trip. So if you want, I can show you some photos from the oil and gas industry. We are now working on changing the industry in an energy transition, so I'm very happy to be with you. So first of all, I'm sorry for the noise. Second of all, in terms of communication, we are supporting any kind of utility modem, okay, that will be able to connect to the devices. So it is controlled by ADMS systems or controlled directly in any kind of Modbus connection, which is connected to our unit. And we are also capable of doing case-by-case adaptation if needed. I hope that answers your question, and I'm sorry.
Okay, thank you. Can you expand a bit more on the grid functions that have been developed, voltage limited, voltage balancing, peak load reduction, things like that?
Sure. What we're looking at, we have multiple use cases, but basically we're operating in the 230, 240 volts in the low voltage grid. 2/3 along the line after this substation. And we have use cases also in Europe. And you could see how with the Ecovar unit, which uses reactive power, we stabilize the voltage in Lithuania to 240, which is the regulated amount. And when we turn off the Ecovar, we see a lot of sags and swells in the voltage.
Just to add on top of that, what you basically see is the operation of the reactive power mechanism, which is capable to deal with any voltage-related or even harmonics-related problems on that specific grid. When we add the additional energy storage system, our smart energy storage systems, we are also capable of managing the right amount of active energy introduced into the grid in a manner that basically reduces the need to upgrade it and manage the peak consumption. And over time, this can be done without adding an additional meter.
Okay, thank you very much.
Yeah, so what is the revenue model for how you're working with utilities?
Let me move to that slide. So it's a interesting question. In Australia, the DNSPs in Australia, you have an Origin Energy representative at the room that could tell you more about that. But the DNSP can own the battery. Where we're looking at in potential pilots is a co-ownership model where the revenue streams come from non-wire alternatives, frequency management, and arbitrage. A little schematic of what we thought about pilots and quantities is on the left. And we're looking at a pilot out of Australia as a place to
All right, thank you.
Again, adding on top of Nadav, it is very quickly. We are looking to become a flexibility service provider, which knows to co-work with the DSO, but we are extremely happy to participate with one of the utilities in field.
Yeah, I think it crashed.
Yeah, Eshel crashed.
Okay, I can go next with just 2 questions before the time runs off. Regarding the Eco Store, how do you assess the feasibility of installing the batteries in a specific pole? I mean, there are any specific requirements that you need to take into account? Because I can imagine there might be some weight constraints, or you can make it, are they somehow modular, and then you can have heavier, bigger capacity versions?
We have one battery, but we also have a pad-mounted version. And we have multiple feasibility studies on different types of poles and mechanical feasibility studies available upon request.
Okay. Cool, thank you.
Okay, we're fine. Okay, Nadav, thank you very much. Have a good luck.
Thank you.
Thank you very much.
Take care.
Thanks, everyone. Have a great day.
You too. Hello, David.
Hi,
Hello,
morning.
Verena. Good morning.
Morning.
Here I am. Okay. So, very good to have you here. We are all in this room waiting for your pitch. So we have 6 minutes, and then you have 6 minutes Q&A, okay?
All right, perfect. Can you see my screen okay?
Yes, perfect.
All right,
Thank
all
you.
right. Start now? All right, I think that means I start. So hi, I'm David Beer, I'm from Cogo. Thank you for giving us the opportunity to present today. Cogo has been trading for 10 years. We have 120 people. We have extensive technology, climate change, behavioral science, education, commercial and banking experience. Screen won't move. Come on, move. Few technical issues. So we have live customer-facing carbon tracking and management solution with 16 banks around the world, with a cumulative reach of 30 million people. Here are the logos of our key partners and 2 examples of banking experience you see there from NatWest and ING. Bring our technology directly into the banking partners' digital experience with their transaction spend data, converting this into carbon insights, literacy nudges, and personalized recommendations. We also have our own R&D app in the UK we use for test purposes, and we want to help you deliver an award-winning home energy efficiency solution that will help your customers retrofit their properties in a sustainable way. So the problem statement is customers are facing a dual climate and cost of energy crisis. It's not easy to manage what you can't measure. Most homeowners don't have the expertise and don't know where to start, the knowledge, the information to make the right decisions. Cogo want to accelerate the decarbonation of domestic homes and encourage the retrofitting of existing properties to become more energy efficient and low carbon. Until now, most solutions that are available are disjointed and lack a joined up approach. We want to join the dots and offer a full end-to-end service. Cogo will provide the expertise, the independence, the insights, the transparency with our carbon management solution, energy efficiency actions, literacy, and behavioral science approach. We want you to provide the energy expertise, the smart energy data, home energy products, services capability, installation experience, and low carbon tariffs to deliver real results. Then we can bring banks into the equation, engage them around real data and commercial opportunities to provide financing options that will allow more homes to be upgraded, encouraging your customers to take the necessary steps with the right data and financing options to retrofit their homes in an easy, efficient, and personalized, customized approach. Together, we'll provide a single point of decision-making for retrofitting these homes and the ability to grow your customer base and deliver real tangible results. So the proposal is we propose running a pilot with you over a 3-month period to test this proposition and create an MVP solution that can be scaled across your customer base. We will de-risk the process because most of the solution is already working in a bank environment. What's needed is smart meter data to be added to our carbon engine with a range of energy tariffs, energy product options, servicing options, and installation options that you can provide. The MVP will test our existing model with your data and options to deliver a range of low carbon features for your customer base. Then we can bring together banks for green financing products to fund the transition. Banks also provide distribution and reach to their customer base, giving us options to offer this product through their distribution channels as they want to look at more low carbon journeys. Where they struggle is having both of our expertise in the room to help them deliver on what they need to deliver. So the three of us together can create a value add end-to-end proposition. So what we work on is a 3-tier approach, if you can see this, around measure, motivate, and mobilize. What that means is you can't manage what you can't measure. We provide your customers with clear visibility of their energy use and the resulting carbon and energy footprint embedded into your existing touch points. This can be built into a smart energy mobile experience or a banking app or a bespoke app. We motivate them, which is vitally important, is critical to drive engagement. We would integrate Cogo's behavioral change framework to take customers on a journey to retrofit their homes. We would also employ nudges, climate gateway actions, energy actions, and engage your users to build trust and promote engagement. We would recommend personalized retrofitting options and packages that would meet their lifestyle and financial position. So mobilize really means giving you the opportunity to monetize the experience, allowing you to build seamless customer journeys that tie together your retrofitting assessments, your products, and your services with banks' green financing to supercharge the transition to a low carbon homes, giving you revenue and reach. Now, finally, our expertise, our team of experts exist beyond just our carbon tracking technology experience. We bring together extensive experience around climate change. We've worked with banks around the world to deploy solutions. We also worked in multi-languages across many cultures. We have behavioral science and insights team, climate impacts team, experienced product implementation and banking experience. We bring together a winning formula to drive real change. So in essence, Cogo is bringing the trust and independence, customer engagement and expertise. You're bringing smart meter data and product options. The bank is providing funding options and financing, and you're providing installation services. Together, we're creating a connected proposition that solves the decarbonization challenge and helps customers make easy, accessible decisions to retrofit their homes. Questions?
Good. Thank you, David. Go ahead.
Hi, Cameron Briggs from Origin Energy. Firstly, congratulations on making it to our top 60. Pleased to see so we're from Origin Energy from Australia. Good to see that you've already made some traction with banks in Australia. Look, I think over the weekend, you've probably got a really good opportunity now to add a new widget to your app, which is probably the liquidity position of the bank that we're actually talking to, which might actually be useful for some people. For a question for us, so we're really keen to see what you're doing. Understanding energy, helping drive customers' awareness and education is a really important thing for us. One of the big segments that we're targeting, besides mortgage owners, are people who might be renting or might not necessarily have that relationship with a bank, and the bank might be more of a credit card type thing. Do you think banks would be open, or do you think there's a possibility to look at those type of applications as well?
Yeah, well, I'll go first, and I'll get Verena to throw in a comment. Yeah, definitely, because what you can do with our approach is you can bring in multiple data sets. So you can bring, if they're a credit card, in other data to actually understand their position. It doesn't matter if they're renting or they're a homeowner. It could still give them options to understand the affordability that they can move in by their own home. Verena, would you like to add to that?
Yeah, definitely. I would like to add a little bit more around the education piece that you talked about. So I think the really big opportunity here, combining energy data with carbon enriched spend data, is that you get a really good 360 understanding of a person's carbon footprint. So we call this journey a carbon literacy journey, where we can engage people already on their day-to-day spending or their day-to-day electricity use, on really building up where a lot of savings can, for example, come from, and what kind of climate action they can take. So I think combining this data will really make this opportunity of education even more powerful.
Fantastic. And have you thought about what you could do? I mean, obviously you're a startup, you have to be very focused, but thought about how you can take people's journey outside the home so it becomes fairly encompassing in terms of their life and their lifestyle? Because that's something that we're looking for, to really meet our customers through the whole journey of what they do, the way they get to work, the way they shop, the way they do many things as well. So is that something that's kind of on your mind or on your roadmap?
Yeah, it's something we're already doing. I'll let Verena answer that question. We do take a 360 degree of everything they do and build a complete carbon footprint for the individual. So
yeah, absolutely. So I mean, I would probably say that this is definitely our core expertise. So we already look at basically the major carbon driving elements of your carbon footprints, and we build really engaging experiences around how people can essentially lower their carbon footprints around the big pillars, sort of like flying, any type of home transport habits, food, and also fashion, any type of consumption. We're building our experiences around our product principles. So we need to make sure that any experience is very engaging. It is relevant to the person, so it needs to be personalized. This is what's lacking in a lot of current solutions. It needs to be relatable, so sort of like meet the person where they are right now and speak also in the type of framing that works for them. And overall, we need to set them up on a type of winnable game, as we call it. So help them set targets that are realistic for the situation that they find themselves in. So these are the type of questions that we are already in my research team answering and asking ourselves every day. And we have about 2 years of research experience in this field.
Excellent. All right, getting really practical now. If we were to do a pilot with you, I'm trying to get a real sense of what we need to bring. So could we bring the relationship with a bank, or is that something you already have established and you're happy to do? Like, I mean, we've got a reasonable footprint in Australia. We know banks quite well. Would that help you in terms of facilitating the process if we were to engage with perhaps other banks as well?
Yeah, for me, it's trying to figure out where the gaps currently are, right? Because I think that it's kind of like the trilemma of bringing together an energy company, Cogo, and a bank together to square the circle of that complete end-to-end proposition that you're providing trust and transparency and going all the way through. We're already working with Westpac, Commonwealth, Suncorp in Australia. You're going to have relationships, we're going to have relationships, and it's just working out what the best approach is to deliver the ultimate result. So we're not going to go in with a fixed mindset to say it has to work this way. It's co-collaboration process to make this work.
Right, and is there anything particular or special? I mean, you asked for smart meter data. There's a lot of companies out there trying to help people sort of disaggregate their energy data and provide them. Is it just 30-minute AMI data, or is there something special that you either need or provide insight that others don't, just to give us a sense of what we need to bring from that perspective?
No, go on, Verena, go on. Do you want to answer
that?
I
was just going to say, I mean, the way we look at the experience is that the more data and the richer and more specific the data, the more targeted, essentially, this proposition we can deliver, but we can also design something sort of like on a more higher level. It is just that the more richness and specific data we have, the more tailored the experience will be.
Excellent. That's answered all my questions. I might, in the last 30 seconds, see if anyone else in the room's got a question.
Hi, it's Samuel from E.ON. Do you have actually data on the engagement you can share?
Yeah, I mean, there's different types of engagement. For example, our R&D app in the UK, we definitely have a lot of engagement metrics on this aspect. So we know that the more sort of like relatable the goals are for people's carbon climate actions, the more engaged people are. Sort of like setting their own carbon budget, for example, is a new feature that we've played around with, and it worked really well. Any type of carbon literacy, so we designed specific carbon literacy interfaces, and the more people engage with those and really understand the nuances of different types of actions also helps a lot with engagement. Overall, our current proposition is mostly like a weekly engagement tool, because people seem to think about their spending on a weekly basis. So then they try to sort of like come back and see how well they did versus their goals. So we have a lot of studies and understanding around engagement and have different approaches towards it. Yep.
Right. I think we're at time. Thank you very much, and good luck.
Thank you.
Thank you so much.
Thank you. David and Verena, you can leave on the right button. Okay.
Thank you. Take care.
Hello. Morning,
Yeah, hi.
Julian.
Hi, how are you?
Good, good. Very good to have you here. So we have 6 minutes pitch and then 6 minutes Q&A. You can share your screen as you want.
Okay. Great. Can I just quickly check you can see that okay?
Yeah, we can see it.
Okay,
It's
perfect.
not in the presentation mode, but you are able to see it.
If this works for you, I'm going to swap back and forth between windows. So
Okay, no problem.
okay.
Thank you.
Cool. Thank you. Nice to meet everyone. So my name is Julian. I'm the co-founder and CEO of Solstice AI. We're a startup out of Australia. We do solar energy forecasting. So we don't just forecast individual sites. We actually find all the solar PV across an extended region and then forecast in aggregate what all the distributed solar PV across the whole region, like a whole state, is generating. And we're coming out of Australia because Australia has the highest uptake of solar PV, and it's particularly relevant here. But I imagine it's increasingly relevant for many other utilities around the world as well. And so the fact that we have so much solar in Australia, it's now more than, I believe, or approaching 1 in 3 homes, means major changes to the way the distribution networks are run. Here's a screenshot of something that happened in South Australia not too long ago, a few months ago. At that point, 92% of operational demand was met by distributed solar. So not large scale, but actually all the distributed solar. So that's really challenging for a lot of network operators to handle. It leads to a lot of instability, high voltage in certain parts of the network, and so on. And that's one part of it. The other part of it is for regions of the world that have wholesale energy markets. As distributed solar PV becomes a bigger part of the mix, as is happening in Australia, these big fluctuations in solar can lead to sudden rises and drops in terms of the total solar generation contributing to the wholesale market, and it can be a part of the reason why wholesale market prices can jump up and down quite a bit. So the better you can forecast solar, the better you can alleviate some of these issues. And so one good thing that we now have is that in the last 5 years in particular, we now have access to new data sets and new techniques that can allow us to forecast all this distributed solar better than before. And part of that is new satellite imagery and satellite data that's higher resolution and more easy to access. And part of that is AI techniques coming out of the computer vision community, where you can start to use this data in ways we haven't used it before. So I'm going to jump straight into a demo. As a proof of concept, we mapped all solar PV in the city of Perth in Western Australia. We picked Perth because we had done a lot of prior work there. So this just shows an overview. Hopefully it's coming through okay via Zoom. This just shows the overview of all the regions we've mapped. And I'm going to dig in a little bit. If we go in a little bit, just to show you kind of the level of accuracy that we have. Here you can see all these yellow polygons. Each of those is the outline of a rooftop solar PV system. And we're very confident in our solar PV identification model. It works really well. We've even trained it to not identify certain types of solar, like rooftop solar hot water, which doesn't actually contribute to the total generation because it just heats hot water systems. So that's one part of our solution. And then another part of it is, just have to move my window, otherwise the Zoom options block it. Another part of our solution is that we forecast the movement of cloud imagery. And so here's just an example of clouds passing across Perth. And every now and then in Perth in particular, you get these cloud bands form as they pass across the city. Suddenly all this distributed generation drops off. So it's very important to know that in advance to take measures to handle it. So free electrons for us is a really interesting project, or a really interesting program, because one thing we need now more than anything is to work directly with utilities and to demonstrate and advance our technologies and prove how much they work. So we've thought about 2 pilots that could work. And so the first one involves basically taking a particular region of interest. It could be the region served by a substation or a distribution transformer or a zone substation. Within that region, map exactly where all the solar PV is, and then look at generating regional solar PV forecasts. And that would provide the outcomes of better understanding solar PV in that region, understanding how accurate these solar forecasts can actually be, and understanding the impact of solar forecasts on operations. The costs would involve the data sets, the overhead imagery, which is a variable cost depending where in the world you look at, satellite data, which is actually cheaper than overhead imagery usually, and compute and infrastructure. And we thought of this as sort of a 10-month project where quite a bit of time at the start does need to go into procuring the data and training the models, which do need to be retrained a little bit as you move from one region to another. Certainly the utility partner we'd work with, we'd look at getting as much data sets as we can. In a perfect world, we'd have meter data for all the solar PV in that entire region. So we'd have an exact ground truth to demonstrate how accurate our forecasts are against. But I know that's often not possible, and then we can work with whatever's available. That's one possible project. A second possible project, which is related to work we're already doing here in Australia, is looking at virtual power plants. And in this case, it wouldn't involve identifying all the solar PV across the region. Rather, it would be looking at what happens if we have a fleet of systems that we're trying to jointly manage in the best possible way. Do we forecast them each individually? So do we do individual solar forecasts, or do we look at clustering them? Because we found in our existing work that sometimes that leads to better forecast accuracy, and it simplifies the solution a lot. So I'm running a little bit short on time, but that's another pilot project we'd love to do. In terms of our team, we are a deep R&D team. All of us have come out of the R&D community. Well, 3 of us, me, Manisha, and Peter. In my case, Manisha's, we've done PhDs. Manisha directly in solar forecasting. Peter has a long history of software engineering and is very, very competent software engineer. Val, our mentor, actually went through free electrons about, I think in 2017, so he knows the program as well. We do have existing traction. We're doing some of this work as part of a project we're contributing to in Australia right now. And I've run out of time. So there we go. We're Solstice AI, and love to talk
Thank
to
you, Julian. Let's move to Q&A.
Hi, this is Samuel from E.ON. Thanks for your presentation. You're right now in Australia, right? Would your service also be available in Europe, or, for example, in very specifically in Tenerife?
Yes, so certainly in terms of the satellite data sets, we've looked into that, and we have similar resolution as Australia available for Europe. The overhead imagery, in terms of finding where the solar PV systems are, depends a bit from one location to another, and I can't offhand confirm 100% that that we would have that. But that would be one of the project costs in terms of buying them from the provider. And I'm guessing I would be very surprised if it isn't something available for 10 years.
Okay, got it. Thank you. And for us, it would be quite interesting to connect your solution to our grid planning tools. What is your vision on that? How do you plan to connect your software solution to existing solutions we might have?
So we're thinking of offering all of this as software as a service, so API-based. So an API you can call both for the identification and for the forecasting. And so hopefully that would make it fairly straightforward to regularly call these forecasts and integrate them into your whatever your tools are. But that's for us actually one of the benefits of taking part in this program, understanding that better, understanding what we need to deliver and how it best works for you.
Okay, thank you. And can you compare your solution to other solutions in the market in terms of accuracy? Did you have any picture on that you can share with us?
So it comes up often this question. Accuracy, you may see percentages on how accurate solar forecasts are, but metrics about how accurate solar forecasts are is like a whole region of discussion of its own. Yeah, let me take a step back. So we have the two solutions. There's the solar identification, finding solar panels, and for that, our metric is that we get about 97% of pixels correct in terms of finding where the solar panels are. In terms of the forecasting, it really depends. Are you talking about individual sites? Are you talking about the whole regional forecasts? Are you talking about clustered forecasts? We have a pretty extensive publication history. Manisha, through her PhD, did a lot of work on this, and pushed the envelope on improving those forecast accuracies. If you want to number it, it's hard because are you looking at Maze? Are you looking at RMSE? What metric do you want the best? I guess to put it in a more digestible way is by adding these forecasts of cloud movement, we get about a 10% increase in forecasts versus using standard methods that are used everywhere else.
Okay, thank you. And can you explain your business model?
Our business model, you mean in terms of like our target clients and so on? We see network operators as a real opportunity in Australia. We particularly see anybody playing in the wholesale energy market space and affected by being able to bid more effectively into the market as a major opportunity, and then VPP. And the business model is offering this as a software as a service by a subscription, which will depend very much on the area covered, the frequency of forecast updates, and whatever other infrastructure is required.
Okay, thank you. Any more questions?
Okay, then one quick one, Anna Trundovic from Future Energy Ventures. I was wondering a bit about the forecasting methodology. You mentioned that the models would need to learn. So in terms of scaling, what would it take to go outside of Australia, for example, to Europe, and what kind of potential challenges would you need to overcome?
Yes, so right now, the proof of concept I showed was for Perth. I actually have a tab up that describes this. So you see the kind of imagery we used when we did this analysis for Perth, and it's kind of blurry and low resolution. So we're now in the process of mapping every single solar panel in Queensland, which is a large state in Eastern Australia. And here we've got much higher resolution imagery. And this is our own internal tool for kind of fixing incorrect annotations. And we thought it would be quite straightforward to move from one data set to another, but we found that this is taking us about 3-4 weeks in terms of building some new training data sets, retraining the model to get the same accuracy we did before. But even 3 to 4 weeks is, to go from one region to another, we think is a tractable problem. Like it just takes a bit of time, but we can.
So quick question on our side, and thank you for the pitch. Getting back to the satellite images, so on one side we have mentioned accuracy, but are the satellite images enough for you to run your models, or do you need any additional data? That's one. What type of information do you actually collect from the satellite images? And then the last one within this topic is how do you get these data sets? So is it from your customer, or do you have any other way of collecting these data sets?
Okay, so there's a few different data sets. There's the data set we use to identify solar panels. That's overhead imagery. That's not actually satellite data. That's usually planes or drones flying overhead and taking images. And for example, for Queensland, the state government had data sets that are made available. There's also a lot of third parties that provide that data for government parts of the world. That's just one type of data. The other type, the cloud forecasting how these clouds move. The satellite imagery in Australia, that's free for us to use for commercial use. And I know there's similar data sets for Europe and the US. Slightly different resolutions and slightly different ways to process or to extract that data, but the same process. Okay,
cool. Thank you.
Okay, thank you very much, Julian.
Very much.
Thank you, good luck. You can leave the room in the button on the right side. Thank you.
Hi everyone.
Hello, Boya.
Hi.
Good.
Good. How are you guys?
Good to see you. So we are now waiting for your pitch. You have 6 minutes, and then you go to the Q&A.
Okay, got it.
You can see our screen already. Good luck.
Cool. So can I just start now?
Okay, you can go.
Okay. Hi everyone. I'm sorry, I'm hearing a little bit echo. Is that normal?
Yeah, it's just a pitch room. Do you want me to mute it while you present?
Yeah, that would be great. That would be great.
Okay.
Thank you.
Okay, I'll mute it, but then you have to activate it again in the pitch room, okay? Just to let you know, Oliver.
Okay, sure. Thanks.
Okay.
All right. Thank you, everyone. This is Boya from Ubiik. So I'm gonna spend like a really quick minute introducing our company. We're Ubiik. What we do is essentially the intersection of telecom and energy. So we provide the communication technologies plus the application platforms to help the utilities to reach grid modernization. We focus especially in the areas like AMI and DER management. So Ubiik was founded in 2016. In the past 6 or 7 years, we have grown into a company with more than 100 employees around the world, and we have been profitable already. Half of our employees are R&D engineers. We have hardware engineers, software engineers, and also AI scientists. So the company is based in Taiwan, but we have been targeting the global market all the time. So as you can see, our team is pretty diverse regarding cultural backgrounds. So let me directly jump into the challenges we're trying to solve. So basically, we're trying to solve 2 challenges in the DER industry. So the first one challenge is we found that the utilities normally don't have a unified platform to interface with so many DER equipment, DER types. So that's what we're offering. So basically, our EMS software is a single unified end node platform to integrate with multiple DER types from different equipment vendors. So that's challenge number 1. And our DER equipment ecosystem is still like growing now. Challenge number 2 is we're trying to turn the behind meter microgrids to be financially feasible. So right now, like many power consumers, they found that maybe like behind meter solar or battery are too expensive to install. They cannot recover the investments. We want to change that situation. So basically what we do is we utilize AI forecasting. We forecast the solar generation of the rooftop solar, and also we forecast the power consumption of the household. Based on the two forecasting results, we do this battery scheduling model to optimize the charging and discharging of the battery dynamically in real time. The goal is trying to maximize the stacked revenue of the behind meter solar plus battery system. We're trying to shorten the payback period of the solar plus battery system to 5 to 7 years, which is gonna, turn this whole system into a financial attractive solution. So as you can see on the diagram on the right-hand side, our EMS software is basically the bridge platform between the DER and devices, and also the DERMS platform or VPP platforms of the utility companies. So this diagram is more detailed. So in the green areas, that's basically the products Ubiik is offering. So as you can see here, we provide we call the smart controller or gateway. It connects to all the different DERN devices, thermostats, meter, battery system, PV, or EV chargers. And also from the smart controller, we connect to the cloud EMS platform as well. So in the EMS platform, we have several functionality modules. We have the core forecasting modules, the solar forecasting, load forecasting. We also have the battery scheduling module, as well as the financial assessments, so that we can keep track of the financial gains for the power consumers all the time, so they know how much money they have saved. And our platform also can interface with the utilities' existing DERMS platform or the third-party VPP or aggregator platforms. We also support the OpenADR 2.b. So this is a diagram. It's a workflow showing like how our algorithms works. We continuously collect the meter data, the weather data, and the satellite images data, as well as other feature data. We feed those data into the two forecasting models, and we do this long-term and short-term forecastings every 15 minutes. And then based on the forecasting results, the battery scheduling model is basically an optimization model. So it's dynamically making the decision for the battery to charge and discharge accordingly. The whole battery scheduling is done automatically, dynamically, in real time, and it's 24/7 without any human intervention needed. So this is how we picture the pilot project with the potential utility partners. So basically, we need some help from the utility companies to get two residential power consumers enrolled in this project. So for these two residential power consumers, Ubiik can provide a total microgrid solution, which includes the solar, battery, EV charger hardwares, as well as our own EMS software. So by having this microgrids established, the utilities can dispatch these batteries whenever they need it to enhance the grid stability. And also the residential power consumers can also gain a lot of financial benefits, cutting the electricity bills, and also go green, use more renewable energy, and again, power resiliency by having the backup power.
Okay, thank you, Boya. You're gonna move to the Q&A right now.
Oh, okay.
Thanks very much for a great pitch, and thanks for joining us all the way from Taiwan. We're in Germany. John McKeon from ESB in Ireland. Yeah, we had interest from two parts of our business, the network side and the retail side. I guess I just want to clarify where you are on the curve, the sort of readiness curve. You described there in slides very well, you know, how you optimize, and you know there are many other people trying to do this. If you've got that kind of system in place, optimize a battery. Very few people have batteries in Ireland at the moment. Some people have solar and EVs, but let's assume it'll start to work. In terms of your fleet of reference sites, how many of those do you have with that configuration? Could you talk to that, and what are the results to date?
Yes, I don't know if you guys can still see my slides or no.
Yes.
Okay, so we do have 3 pilot sites in operation in Taiwan right now. So in the slide, it's actually showing one of the sites. So all these 3 pilot projects are under operation and they're running normally. So as you can see, we have solar, we have battery, and in this set specifically, we also have 8 kilowatt level 2 EV charger as well as part of the load. So what we do is our system basically do the solar self-consumption, time of use average price. We do the peak shaving to avoid the demand charge, provide the backup power. Basically, we coordinate and co-optimize all the revenue streams all together to maximize the financial revenue for the power consumers. So in Taiwan, the electricity price is pretty low. It's much lower than Europe, Japan, or US. So right now in Taiwan, we're making that barely break even for 10 years period. So we believe that if we do that in Europe, in Japan, in US, with a much higher electricity rate, we're gonna turn this payback period to maybe 7 years.
So outside of Taiwan, do you have any footprint with projects already?
Yes. So these are the 3 projects regarding the DERs, but we are also one of the largest AMI vendor in Taiwan. So we have deployed over 650,000 smart metering communication infrastructure already. So we're actually the leading vendor in Taiwan right now, but DER is just our new business. We just started that last year. The 3 projects I'm showing to you are still in the commissioning phase. So it's still validating all this software performance and everything, including validating the business models. So everything is going pretty well as expected right now. It's just a new business unit we're kicking off right now.
So this application is of interest to us. So, and when do you think you'll be ready to do something in Europe?
We actually can do that right away because we already have the partners can offer the battery and the solar inverters, hybrid inverters, and also EV chargers. So those hardwares we have already completed all the integration with our software already. So we basically can provide a bundle solution, and all those hardwares already passed all these IEC and UL certifications. So they're ready for European market, also for US market as well.
Hi there, it's just Saoirse from ESB. There's just a question in the chat. So can your EMS manage microgrids formed by several buildings, facilities and so on, or is it just limited to a building like the pilot you're showing here?
So our EMS is basically within a single facility level, but we can definitely interface with third-party VPP or the Utiligize Pitch platform to enable aggregation. But we're more focusing on the control and management within a single facility.
Any more questions from the floor here?
Yes, I had a question. Gordon Thompson from E.ON. My understanding is your solution is a cloud-based EMS solution without a hardware component. So you would interface with the manufacturer's APIs, correct?
We do have a hardware. It's called a smart controller. It's basically a gateway. So each facility, we need to install a smart controller. So from the smart controller, it communicates with different DER hardwares through either Wi-Fi or RF or RS-485 wired communication. So basically, we have one piece of hardware, which is a smart controller, but 80% of our solution is on the EMS software side. It's a cloud-based software, yes.
Good to know. Thank you.
Yeah.
Yeah, we have one more technical question from our business unit back in Dublin. So what protocol is used to integrate the DERMS?
Okay, so if you talk, so we have two levels. So from the smart controller level, we interface with most of the DER equipment through Modbus TCP because that's most of the vendors are having. From the software, cloud software perspective, we can interface with the DERMS platforms through OpenADR 2.0b. Or we can interface with third-party VPP platforms through their proprietary API. So we do have a VPP partner in US market right now. We're interfacing with them through their proprietary API. But for the other application platforms supporting OpenADR, we can also do that.
Okay, thank you. And thanks to Kieran for that question back in Dublin. I think we're out of time, but thanks very much. Great pitch and fantastic technology, and well done you for, what time is it over there?
It's actually almost 5 now.
Not too bad. Go and have a beer. Thanks very much.
Okay, all right. Thank you, guys.
Thank you. Bye-bye. Well, you can leave the room, the right button in the menu. Thank you.
Yeah.
Hello. Hello, Krasimir. Hello, Julian.
Hello.
Very good to have you here. You are ready to listen to our pitch, so feel free to start at any moment.
All right. Oh, it should be okay now?
Yeah, you can go. Thank you.
All right. Thank you, everybody. I'm Julien Martinac, co-founder of Tokwise and in charge of development. And I'm here with Krasimir Polev. She's as well co-founder of Tokwise and in charge.
Sorry, Julian. Can you speak louder, please? Your microphone is very low.
Right.
You can try now.
Like this?
Yeah, we can try. Please go.
Yeah, Julien Martinac, can you hear me well?
Yes, good. Thank you.
Okay, good. We are very happy to present you Tokwise today and discuss potential synergies. Here at Tokwise, we help energy market players to buy and sell electricity at the right price and at the right time. And this is a critical challenge for utilities that have more and more green electricity in portfolio, because they need to handle energy usage behavior, intermittent renewable productions, increasing market volatility, and rising competitions driven by an increasing marketizations. And as a result, capture margin are uncertain, and it impacts investment capacity of organizations and the growth of the portfolio. Buying and selling electricity at the right price and at the right time is a strategic priority for energy companies. But the decision process is becoming more and more complex because energy portfolio managers need to provide a lot of information, and decisions and executions has to be done in a couple of seconds. And that's a problem which today is becoming too complex for a human alone to handle. And that's exactly the problem that our platform is solving. We enable energy portfolio manager to take fast and accurate decisions, taking into consideration what's happening in the physical world, but also in the market world. And thanks to our algorithms that are powered by artificial intelligence, that are going to identify what are the best strategies to be executed, and this in a few milliseconds. So here is an example of an ongoing project we have with energy. So our solution is used to optimize the trading strategy on day-ahead and intraday markets. So we work with our short-term trading desk, and we work for the French portfolio. As you can see, as a result, we are decreasing their balancing cost by 30%, which represents 1 million euro net revenue increase if we look at 12 months. Here's another example of ongoing project we have with two large German aggregators. In this specific case, our solution is used to optimize asset flexibility trading on short-term market again. And with competition increasing, we play an important role in helping Sonic and Baeva developing a competitive advantage on the market. What makes us different from competitions is that we have designed a scientific approach to energy trading as from the beginning. Contrary to organizations that are going to multiply the number of trading analysts, multiply the number of screens to manage the complexity of the new ecosystem, we rely on artificial intelligence and a large number of data sources, which allow us to offer to our client the scalability and optimize return with better predictability and lower risk. Furthermore, we have an attractive economic model, which makes the start of our project quite easy for the clients. We have a setup cost, which usually has the return on investment within a couple of months. We have a monthly fee that will depend on the size of portfolio, meaning that we can start with a small portfolio or part of the portfolio and grow together with the client. And we have a profit sharing component because we believe that's a win-win approach, which is based on KPI we define with client and which is tied to the performance of our solutions. Regarding the collaborations with free electrons utility partners, the position will be to leverage our solutions to develop custom trading strategy on short-term markets with the goals to decrease and control balancing costs, which are going to grow more and more for any energy players in the near futures. So we strongly believe that we can bring a lot of value and increase the capture margin of the portfolio. Now, wish today would be to understand if you see the same potential synergy that we envisioned and if this kind of solution, this kind of approach would make sense for you. So thank you very much for your time, and I think we're happy to take some questions now.
Okay, thank you for the pitch and for the presentation. I'll kickstart with one or two questions, and then for everyone from either EDP or all the utilities in person and online, feel free to add something on top. Can you detail a bit more on the sources for market insights? So what you had there, a slide with the information that you have and that you are using for the market insights. Can you detail a bit on that? And then also on the forecasting model. So how is actually the energy production forecasted? Yeah, we cannot hear you. No.
Okay, maybe I can take the question until Julien fixes his microphone. So to your first question about the sources of data, we are using a few buckets of input data. On one side, this is data that is specific to the portfolio of the client. So it could be metering information, SCADA, it could be some forecasting providers used by that client, and etc. So asset-specific data that we receive from the client. The second data is more third-party providers where we get some market information. For example, the market prices, the imbalance prices, the grid status on the market where we operate, the activated reserves, which impact the grid situation, etc. And the third bucket is more open data in terms of weather information, commodity prices, etc. So we always try to increase the number of the features, the inputs that we're using, But of course, we need to be conscious that we need to add a new data stream and prove that it will actually help our model and is not going to bring some noise. In terms of your second question on the forecasting of the energy, it could be production or consumption, I guess. We are working with the forecasting providers of our clients. They are market leaders on the that are used by the biggest companies, which provide a quite accurate production or consumption forecast based on the weather conditions, solar radiation, wind, etc. So we are leveraging these as input and try to implement optimization layer on top and try to actually compute the most accurate prediction for the client portfolio based on which provider is doing the best for which asset.
Okay, cool, thank you. We have a question on the chat, which is, what is your business model and is your goal to sell software as a service?
Correct, our business model is a combination between monthly license fee, which is based on the country instances for a client, whether it's operating on one or multiple markets, and based on the capacity of the megawatt that we are managing. We also introduce the profit sharing to introduce this attractive model for the optimization service that we offer. However, we would like to keep this profit sharing as a small percentage and be mostly focused on the recurring element from the monthly license. So the profit sharing is a small one.
Okay. Any questions in the room?
Yes.
Ivan, go ahead.
Ivan from CLP. Do you foresee any difficulties if you are considering a pilot with us in mainland China, specifically on RE price forecast?
Yeah, so we currently, as Julien showed in the presentation, we're currently mostly focused on the European market. Our R&D team is constantly looking how we can go to other countries, other markets. So we'll be interested to take a look at the Chinese market. However, we need to just be conscious that we will need some time to look at the market specifics, the dynamics of the market computation, etc. Which I don't see as a challenge, but it's just something that we need to envisage.
What kind of key data that you think would need our support? Or what kind of data that you think can rely on yourself?
So I guess it will be mostly from the client. What we usually request is the data related to the portfolio, so production or forecasting or availability signals of the portfolio, if we assume that it's mostly from renewable assets. And what we need to also get in that case is the market relevant data, because I'm personally not familiar with the Chinese market. What are the sources for that? But I guess that there will be some sources of data that we can leverage and actually get the information about market prices, imbalance prices, etc.
Can I go back to the sorry. For the questions on the chat, can you expand on the client-specific data that feeds into the AI model?
So client-specific data, I guess that we've covered that just 1 minute ago. Here, what we mean is data related to the production of the assets from the client portfolio, which are in scope of our service. We request usually historical data for, let's say, up to 2 years, forecasting data if the client has such, and also availability data in case there are any outages or maintenance that have been planned and executed. So this is what we request usually from the client.
I think we are running out of time, right?
Okay, thank you. Thank you very much, Krasimir, Julien.
Thank you.
Thank you. See you. You can leave the room.
Bye-bye.
Bye.
Okay. So now you know the drill. It's what we did yesterday. You discuss amongst yourselves. You took some notes. Once you've reached some numbers, conclusions, thoughts, place them visually on the canvases, and then we do a roundup. Oh, if anybody's still online, thank you very much. We'll be doing a debrief right now. It was great having you here. Thank you. So after which we run all of them, and we have a break for the next before the next pitches, which is at 11. Okay. Discuss. You know, but there's work to do. Yeah. So Blade, shall we switch? Haru, welcome them in. Actually. Chris. Let's welcome Chris. Faça boa figura. Tem que fazer boa figura. Oi. É, claro. Yeah. Hi, Chris. Welcome.
Thank you.
Hi. So congratulations for making it this far. You
Thank
have
you.
7 eager utilities wanting to listen to your 6-minute pitch, and then have 6 minutes for Q&A. So if you're ready.
I'm ready.
Set. Go.
Okay. Okay. Can everybody see that?
Yes.
Okay. So thank you firstly, thank you for the opportunity to present to you all. I'm very happy to be here. My name is Chris Cheshlak, and I'm the founder and the CEO of Bladebug Limited. And it's moving. Yes. Bladebug is a robotics company, and we are on a mission to effectively make wind turbines operate better. And we want to help accelerate the transition to net zero. Now, we're going to achieve this by removing the risk, the cost, the complexity of performing detailed inspections and early stage repairs on wind turbines through the use of robotics and automation. So wind turbines are huge complex structures, and they're getting bigger and bigger. The next generation of wind turbine blades will be in excess of 115 meters in length each. And these will be located on wind farms that are, hundreds of kilometers from the coast. Now, the blades are, from my point of view, the most critical part of a wind turbine. And if they're not operating in their sort of optimum condition, that directly impacts how much energy is produced and how much CO2 is therefore saved. Now, the status quo of relying on rope access technicians to carry on maintaining and repairing these blades, it's not the answer. Robotics and automation will drastically remove the reliance on humans to perform these risky and repetitive tasks, whilst at the same time improving the quality whilst reducing the costs. Now, this isn't about job displacement. This is a situation where there's already a huge skill shortage within this sector. Over 500,000 workers are required to be trained by 2025. So what is Bladebug? Well, Bladebug is a patented 6-legged walk-in robotic platform that adheres directly to the surface and changing surface of a wind turbine blade. And it enables detailed inspections or repairs to be performed remotely. So it's an agnostic platform, essentially. Now, interestingly about Bladebug, it's designed for the offshore wind sector first, and this is governed its size and form factor. So it's small, it's compact, and it's lightweight. And that means that it's got easy logistics to and from site, which is really, when you're thinking about offshore activities, that's really essential. Now, the robot consists of 2 elements. So firstly, it's the robotic platform itself, this multi-legged robot with 6 independent legs that can use vacuum to adhere to the blade surface and automatically adapt as that surface changes as it walks along. And then the second part to it is a modular tool base. So we can easily change the functionality of the robot from an inspection device to a repair device by quickly and easily changing its tools. Now, the robot enables more proactive approach to inspections and repairs, and the idea that this can save you a lot of money by reducing things like lost performance through things like blade erosion or unplanned or extended shutdowns for blade repairs. Now, we've been very fortunate that for the last 4 years, we have developed every single stage of our robot in collaboration with the offshore renewable energy catapult. And so we've tested on, you know, from a single cup on scrap blades in a car park to our full MVP on wind turbines. And these include a 2 megawatt onshore turbine in France and a 7 megawatt offshore turbine in Scotland. But what we're here today for is that we need more time on turbines. We need to be on different turbine sizes, different types. And this is where, you know, speaking to you is really essential. This is where you come in. We now have an MVP robot capable of performing detailed ultrasonic non-destructive tests remotely on wind turbines. And we're looking for things like subsurface defects within the blade that you cannot see from a non-contact visual inspection, say from a drone. Now, we're looking for piloting partners to work with us by providing time and access on a variety of different wind turbines, initially onshore to benefit from the lower costs and the easier logistics, to demonstrate and validate the current Bladebug's deployment methodology, make sure it works on all different types. We've never been on a direct drive turbine, for example, but in parallel show that the robot, the task, the high value task that we're performing is really valid, and we expect to be able to offer at least a 33% saving over what you can currently do with a rope access technician. And so it's fantastic to see all the companies that I'm speaking to now that have wind either currently in their generating portfolio or it's in their pipeline as they transition to net zero. And in particular, EDPR, E.ON and ESB, who have onshore and offshore assets in the UK, which is where we're based. So this is a really good opportunity for me to sort of showcase what we're doing to you guys. Now it's fantastic that we have this opportunity, but what we're looking for is up to 20 pilots, where a single pilot would include sort of following steps, where we would have free access to wind turbines with a authorized technician to stop and fix the turbine in a certain position. For a new turbine type, we'd like 1 to 2 days of familiarization, understanding different rigging requirements for that particular turbine, and then 1 to 2 days of time on blades with known defects that we can then perform our ultrasonic inspection and show the benefit of what we're doing. But, we would like to do more than just that. We want insights, issues that you currently have. Our robot is a platform. We can develop tools to solve your problems, and so it's really great to be able to get what those issues are firsthand. So we're currently a team of 10 people. I'm a wind turbine blade designer through training, and we have our Akshat Shah, our CTO, electronics engineer, developed our first bipedal walk-in robot at Imperial College, and Stacey Rivers, who is our business development manager with 27 years of subsea experience. We're also joined by Peter Childs, our chair, the co-director of the Future Energy Labs at Imperial, as well as been involved in many other businesses.
Great.
Okay, so
yep.
That's my time. Appreciate that. So,
all right, thanks, Chris. We have some questions for you.
Perfect.
Yeah. Chris, I'll kickstart with some questions, and thank you for the pitch. And I then would also invite our teams that are online, EDP, EDPR, Ocean Winds, also to add some questions on top of it. I would start with just trying to understand one thing about the service that you provide. Do you think is it more focused on blades repair or inspection, if you have to compare both? And then based on that, your idea is to sell the Bladebugs or the service?
Okay, so in answer to your first question, it's actually not inspection or repair. It's both, but we do see the bigger value being in the repair element. However, by removing the complexities of really complex inspection tasks, there's a high value element to that as well. So the ultrasonic inspection, for example, following on from drones. Our business model is to provide the robot as a service to industry. So we would not be providing the service long term. We would provide the robot as a tool to the industry to use and basically for everyone to benefit from its functionality.
Okay, cool. Going at the robot itself, one or two slightly more technical questions on the robot. So, like, what is the autonomy? Is it battery powered? How does that work in terms of autonomy? And then, assuming that is battery powered, how long it would take to fully charge?
Okay, so the robot is currently tethered, so we have unlimited power and runtime. So that isn't affected at all. The level of autonomy, it's currently semi-autonomous, so we still have a human operator that has a essentially an Xbox controller to maneuver the robot, but the robot scans the surface of the robot and automatically adjusts its position of its feet to the changing surface of the blade. And the idea being that that level of autonomy will increase over time as confidence increases, as people demand increased levels of autonomy. But we expect that person not to be on site. The idea being that the robot can be remotely controlled, be it from an onshore control center, whilst the robot is operating away from site.
Okay, but it would need, even if it's not on site, it would need an operator anyway, a sort of technician that wouldn't, so it doesn't need to be side by side to be operated, but it needs someone remotely. Is that it, right?
Correct, and the idea being that you can upskill existing technicians who are on site, who might be doing work on drivetrains. You can upskill those people to then be able to either deploy the robot, but then also operate it as well. So you're basically getting a high utilization of staff offshore or onshore as well. You know, it doesn't really matter, but there's bigger benefits offshore. But the future version in the next year or so will be aerially deployed, which would actually and potentially remove the need for any personnel on site to deploy the robot.
Okay, cool. Final question on my end, and then we have some questions on the chat. In terms of a pilot, do you have an order of magnitude for costs and how that would look like?
Yeah, so the cost for a pilot, it's about £5,000, so I guess sort of 6,000 euros per pilot. So, you know, if we're looking for 20, that's sort of up to the cost of like a sort of 100,000, I guess. But it's, you know, the idea being that we want to get a significant number to get some good statistical data in terms of timings, cost, benefits. But that's the kind of cost that we're looking for in timescales. Starting from now, we're ready to deploy.
Okay, cool. Going to the questions on the chat. What are the operational conditions of the equipment? Wind speed, rain, humidity, temperature?
So currently we can operate at higher wind speeds. We can operate up to 15 meters per second, so beyond that of rope access technicians. The current robot is not weatherized because we're still maybe sort of doing modifications to it. But the idea being that the robot will be able to operate in wet weather conditions, low light levels, nighttime, for example. It's not bothered by the environmental conditions.
Okay. Then different question, do you intend to take control of the WTG yourselves, or do you always require an ATCT to be provided by the site owner?
I think to be determined. I think initially, because I think the idea being that the robot will be provided as a service, if you're the owner operator, you would have that in-house anyway. Over the pilot trials, I'm not sure. It depends what level of training is required in order to do that. So I would like to be able to do that because that makes the complexities of trials a lot easier if we're able to do that in-house.
Okay. Is there considerable time required to set up the robot per blade?
No, it's really fast. So we can arrive on site and within 30 minutes be on a blade. It's a very easy process where no personnel needs to get out of the nacelle onto the blade. So no rope access training people are required, but it's a very fast process to get onto the blade.
Okay. You mentioned that you want to make further pilots. What do you have in mind? Inspections, LPS, US, maintenance?
Yeah, so we are focusing on the inspection element at the moment because that uses existing tools that are already proven in the industry. So be it the ultrasonic non-destructive testing or the LPS probes from Mega, we can do all that. But the repair side, that's more bespoke tooling. So we have started to develop leading edge sanding tools, and we see that being a real big benefit going in the forward, where we're able to sort of perform remedial work to the blades once we've identified how serious those defects are.
Well, I'm rushing with the questions. We have a lot of them in the chat. I don't know if there is any in the room. No. So go ahead. You have the last question.
Yeah. Do you foresee any difficulty to conduct pilot in China or India?
Yes, just in terms of logistics. So I mentioned before, we're a UK-based company, and in terms of getting the robot to and from different jurisdictions could be a hassle. I know from experience when we've taken the robot to France before, there is quite a few logistics in terms of getting carnets and temporary import-export visas across. But I don't know, for example, the challenges of getting into China, but our preference would be initially, at least, for the UK or Europe.
All right, Chris, thank you very much. It was
Thank
great
you.
hearing. All right. And we get back to you in a couple of weeks.
Okay,
Thanks.
cheers. Thank you very much.
Bye-bye.
Bye-bye.
I think there's a button to leave the room. Yeah.
Okay, somewhere.
Somewhere in the bottom.
I can't see it.
In German, it's Raum verlassen, but you probably have it in English.
I got it now. All right. See you later. Bye-bye.
All right, cheers. Hi, Emil.
Hello.
Kyle, how are you doing?
Good, thanks. Yourself?
Great, thank you. So congratulations for making it this far. You have here a room full of 7 utilities eager to listen to your pitch. As you know, you have 6 minutes, then 6 minutes of Q&A. Make good use of it if you're ready.
We are ready.
All right, then let's go.
All right, sharing a screen.
It's coming up.
Yeah, so my name is Kalle.
Yep.
I am the CEO of Utiligize. I'm a power system economist, and me and Emil are co-founders. Today, Emil will do the presentation because of his beautiful English. Okay, so the problem that we are solving is over the coming decades, decarbonization means the electrification of transport, heating, and industrial processes. And in many areas, that mean a doubling of capacity. So how should a utility invest in assets to avoid a doubling of cost? This is the problem that we solve with Asset Life, which is our software as a solution, software as a service solution. It has 3 modules: forecast and investment, which is real-term and long-term scenario planning with voltage and ampere calculations for many scenarios, all the way down to the low voltage. We're doing dynamic N-1 and topology calculations. So how should you how to structure your switches? Then we have our maintenance and planning solution, which includes a mobile app for iOS and Android. It's a task management system that registers everything utilities workers do in the field, inspections, repairs and maintenance, data collection, so on. And finally, we have our reinvestments module, which is the most comprehensive open source reliability package available today. And you can download that from GitHub. Today, we're going to be focusing on forecast and investment. Forecast and investment can deliver a capex reduction of 35% compared with a business as usual scenario. We do that with intelligent identification of distributed energy resources in your current grid. And that can be through visual machine learning, where we have some ResNet models, and energy disaggregation. We see that cars are parked 90% of the time. So where they're parked now is where the bottlenecks are going to occur in 5 to 10 years' time. Our optimization reduces investment through extended lifetimes and through flexibility activations. And when you look at existing old-fashioned solutions, they rely on historical data, static topology, and imprecise simple customer profiles. And they simply give the wrong investment decisions. Now, I'm just going to very quickly show you within 60 seconds, what is Asset Life. So we have the dashboard here. You also have all the results and controls available through APIs. Here we have a demo customer with 30,000 installations, and using this is a scenario that we've selected up here, and these are the results of the scenario. The color shows how loaded the transformers, that's the circles are, and the lines, this is a 10 kV and 0.4 kV grid. And this is the results of a simulation that we're running continuously, starting in 2022 and going out to 2040. So we see as loading increases due to increased number of heat pumps, solar panels, and EVs in the system, we see investments being required. That's the euro icon, and flexibility activations according to our mixed integer optimization being required. That is the battery icons. So this is giving the investment and flexibility plans for the future of the long-term pilot that we propose. We also do short-term forecasting. So we can provide, and we would like to offer you streamlined 3-month pilots from start to finish. From your side, we would have bi-monthly meetings, so twice a month, with 1 or 2 asset managers or grid planning experts. We would look to implement this in one critical part of your grid. So it could be a city or region with high renewable penetration or a lot of distributed energy resources already. We see a very strong correlation between electric vehicle owners and affluent parts of areas. So we're going there, targeting there, or a weak grid first. It will generate the most value. The data that we require is 1 year of smart meter data and a GIS snapshot. The KPIs that we can be measured upon in such a pilot is a 35% reduction in capex compared to your existing investment plan for the pilot area, and that's by also maintaining reliability. We will identify 80% of the current EV charging points that you have, be able to identify how they're charging, when they're charging, are they impacted, do they exhibit price elasticity? And for the real-time forecasts, we're doing all the way down to the low voltage pole level, a 5% mean average percentage error. The team here in Copenhagen is building Europe's #1 asset management solution. Half of our in-house team is power system experts, PhDs, economists, people with a background from the power system. We also have a professional board, and then we have outsourced our front end and mobile development.
And we have local presence in Norway.
And we just got our first local presence in Norway, that's right. So today we're doing investment and maintenance planning, and we're currently developing MDM systems, meter data management, tariff and payment systems, and a full GIS suite. And in the future, we will be developing SCADA and flexibility options for real-time operation. We have 5 customers on multi-year contracts, and they're using us for all of their investment decisions. And in fact, we've got a quote here from one of our first customers at Enverforce that their entire IT strategy is built upon our asset management platform. So we did it with 15 seconds to spare, but that is, thank you for your time.
And we can just add in 10 seconds here that all our customers, all the strategic investments are based on our system.
Okay, so low code. Good. Thanks. We have a few questions for you.
Great pitch, guys. Conor O'Brien here from ESB. We've seen a number of forecast planning systems, FlexiGrid, FutureGrid, etc. What's the USP that you guys bring?
I think when you look at some of the competitors, you named FlexiGrid, the amount of data they're looking at is just a few days when they're doing their load flow. The real value is the investment models that we have, because we've done it for the Danish Energy Agency, a 20-year investment plan for the whole of Denmark. It's been a 10-year journey from some of our perspectives through our PhDs to develop this investment model that maximizes social welfare, considering spot prices, flexibility, and the age of the grid. And so I think that we don't see others being able to deliver this 35% reduction in capex.
Okay, and just to touch on that point, 35% reduction in capex is quite significant. Have you previous use cases that actually demonstrate that?
So the big one for us is the public report that we did for the Danish Energy Agency, where when you use fixed lifetimes and very, very simple modeling approaches, as utilities have been doing when we started the company using Excel, that is where the 35% difference comes in. And in fact, it's quite an interesting discussion we've been having in Denmark about if we just start doing things in a data-driven way, and also at the medium and low voltage grids, because 80% of the asset base exists at medium and low voltage grids in Scandinavia, and it's there you can make the biggest savings.
Yeah, and you can also add to that some of our customers have the expectations of digging up the roads twice, which are of course not economically efficient. So helping companies, DSOs, not doing that will also contribute to the 35% in the capex reduction. Yeah.
Okay, no, that makes sense. In terms of deployment, are you cloud-based or on-prem?
We are cloud-based. Everything runs in Docker containers. So if you have a very good on-premise infrastructure, then we are open to on-premise. But today, our existing customers are all using our cloud solution.
Okay.
Which are hosted in the European Union.
Okay, no, that's good. What sort of numbers of smart meters are you looking for a pilot?
So we are looking anywhere between 150 and 500,000 smart meters for a pilot. That is typically, I mean, ideally, it would be over 500,000 because anything under if it's a small utility, then a pilot doesn't make so much sense for us. But medium and large, then we would look at a city with 500,000 smart meters. Yeah.
Okay, I'm just gonna ask some questions here from our chat. What flexibility criteria do you use? Is it probabilistic, associated with different EV charging settings, and how local aggregated? Is it locally aggregated?
Yeah, so actually, yeah. So our flexibility model is deterministic, and how we handle uncertainty is by having a range of scenarios, but we're not optimizing across scenarios. So you would call it a deterministic model. Flexibility in our model is actually activated at the point of common coupling. So often at low voltage. And by looking at a long enough time series, several years, you actually capture a lot of the coincidence factor, and the uncertainty by flexibility diminishes because, of course, at low voltage uncertainty is enormous. But if we just have enough time series and we're running multi-year simulations, then you can cover yourself and get a full range of outcomes.
Of the 5 references you have there, which one is most advanced, and what are the top 3 key results so far?
I think the Type 4 customer, because they've been with us for a couple of years now, is most advanced. What we've done is validated a lot of our results with them. Also looking at the uncertainty of our long-term scenarios and our short-term forecasts. At the 60 kV level, we see a mean average percentage error of around 3% with them. They're also one of the best use cases because they have a large industrial base. They have the highest mean loading per customer in Denmark. And they have around 180,000 customers, I think. And they, what's interesting with them is the number of failures that they've had, and we've been able to predict them. We have in the dashboard, we have a list over all the most exposed assets, and the ones at the top of the list are the ones that will be failing. And they have a 9-month lead time in getting new hardware in, so they really have to prioritize carefully using our tools.
Yeah, but they have also improved their reliability significantly after we have been able to provide them with a list of transformers that are overloaded. Yeah.
Okay, thanks. So, some of our BU guys are online, but we'll be reviewing this over the next couple of weeks. Can you share the results with us from that project?
Those are commercial results, so we would have to ask Type 4. I don't know. I think they'd probably say no, but we do have our public report available on the Danish Energy Agency's website, 70 pages. We also have some results from Ecogrid, which is one of the largest flexibility demonstrations.
We're out of time, but just as a top tip, I don't think anybody is going to buy the grid in Denmark from here. So I don't know where Trafe are, if they're in Denmark. But if it's possible for our BU guys, it would help you if our BU guys could talk to their BU guys. Generally, people who own grids aren't worried about other people because they own their own grid. So, top tip: if you could make that introduction, would enhance your chances of making it to Dublin, the exotic city of where everybody wants to go. Thanks, guys.
All right.
Okay, cheers. Thank you.
Yeah. Okay. Thank you. All right, and we'll be reaching out to you in the next couple of weeks. Thank you again. Cheers.
Cheers. Cheers.
Bye-bye. I think you have a button there to go to the other room. Yeah. Bartosz, hi. How are you doing?
Oh, very good.
Hello.
How are you?
Welcome. So, congratulations to making it this far in the program. You have here a room full of utilities eager to listen to your pitch and more about DataBridge. So, we'll have 6 minutes to pitch, then 6 minutes Q&A. If you're ready, we
yes,
can go.
I am. Thank you and great to be here.
Go ahead.
All
Showing
right.
up, we can see it.
I hope you can see my screen now.
Yes.
All right, so we can start.
Please do.
All right. Hello, everyone. Sorry for this unusual conference room. We are right now in Amsterdam at Future of Utilities conference. So if some of your colleagues are here, so it will be great to meet them also. But let's start with the topic. So what is the logic behind our vision? In 2015, Michał Kosiński from Stanford University developed algorithm that allow, based on less than 300 likes, to judge personality of a person even better than his own family. And in Europe, in European Union, we have almost 300 million of smart meters, and each meter collect data every single hour, which is ocean of a data. And energy sector in 2023 is big data by its definition. And experiment of Michał Kosiński shows that from data we can extract very valuable data. But we ask ourselves the questions: what is the most important? What we can extract for the energy sector? And the most important thing is energy transition to renewables. Renewables are not stable, and we started to think if we can find knowledge about the customers in the grid that can slightly shift their consumption and help to balance the grid, it will be big advantage that will allow to save distribution system operations millions euros on investment, but also will help with this whole energy transition. So we found that data breach in 2019. We started as a small group, but right now there is 12 people from 3 different sectors: technology, data science, and energy market. We have a partnership with 3 technical universities, and one of them is Polish Academy of Science. We get the grants of 1 million euro. We have a couple of pilot projects behind us, and we are ready to scale up. And what distinguishes us from other entities, startups that are working on flexibility? We see across Europe a lot of small pilots. People try to, on a small scale, call to the customer, aggregate them somehow, and ask, can you behave in this way or another? But if it was efficient, why Google is not calling us every day, asking a question about our personal life to better position commercial advertisement for us? And basically, this is big data, what we always repeat, because it means the bigger model you have, the more data you have, the more accuracy you will get. And in our model, we have right now 3 billions of single meter standing. We check different behaviors of the customers, different patterns to help DSOs balance the renewables, and we can help every DSO in every utility group with this issue. So basically, this is what we are doing. We are checking the aggregated profile, or the, let's say, the whole portfolio of the smart meters in the portfolio of DSO, and then we split it, and then we check and we take a look which customers, under what conditions, in which circumstances can change their behavior, and for example can act as a virtual power plant or virtual storage. And what is the most important, we not call to the customer, we do not ask them, are you able to do it, but we know it in advance. So if DSO has a problem because there is overproduction from, for example, PV or wind or whatsoever, we can show them in the portfolio which points of deliveries can switch their consumption and basically take over the surplus of this electricity. And how does look pilot with us? We focus on the most urgent problems that exist in the grids, and in many cases, this is the renewables, and basically change the structure of the grid from the model with big producer to the diversified model when there is a lot of different sources of productions. And then we are finding in the data the most efficient way of solving it. So if distribution system operator in your group has a problem in some period of year under some conditions, and basically is planning to build energy battery storage or to make some other improvements, investments, assets already exist. They are on the side of end users, and basically we, with our knowledge, can can say how to use those assets that already exist to help the situation in the grid. The pilot took from 2 to 8 months. We fully dedicated 4 experts to this pilot. It costs $15,000 US dollars per month. And outcome of this pilot is a report which shows what we did, what kind of the milestone we achieved, what models was tested, what are the results, what is the accuracy of the model. It can be used for the further work on the DSO side. And of course, we prepare a roadmap for further business implementation. If we make a pilot, we see that it works, then it's good to consider to do it on the bigger scale. So basically, this is it. Yeah, and if someone is in Amsterdam, we will be very happy.
Yeah. Thanks, Bartosz. That was great, even with time to spare. We have a few questions for you.
It's on?
Yep.
Hello. Dzień dobry. Dziękujemy bardzo za prezentację. Jednak będę musiała chyba kontynuować po angielsku. So this is Joanna Nelson. I'm from Origin Energy in Australia. We don't have a distribution business, but we do have partners, distribution networks in Australia that we are piloting with around flexibility solutions. So really interested in that presentation. Thank you. Just with the pilot, I did enjoy your analogy in your application around the Egyptian mummy. I was a little bit confused, but what would you need from the utility to participate in the pilot? Like provision of data, what sort of information would we need to provide?
Okay, thank you very much, and your Polish is perfect. Really, very nice to hear that. And but to answer on your question, we always use a couple of data sets, and because we do not focus purely on energy data. This is the core, and this is the part that we will need from the distributor. Those are 1 hour data, 15 minutes data. It depends what they have, but we work with all standards or most of the standards that exist. But on top of that, we use the data from the weather, from the economy. So we also use open source and yeah, but from your partner, we will only need the profiles. It depends also what kind of issue we will solve. Sometimes when we go a little bit deeper into the behavior of the customers, like churn management, or they a little bit more on the commercial side, then we need also some commercial information. But I think in this it will not be the case. So from the DSO only energy data, but we will use also other data from open source.
Okay, and in terms of how the platform would work, you'd need a lot of participants on the platform, yes?
Yeah.
Other VPPs, aggregators, distributed large-scale industrial assets, those sorts of things?
Yeah, so we try to turn this model other way around, because you're right. There are platforms. Right now we see in Europe a lot of pilots with platforms, but the biggest problem that everyone has, aggregators, the distributors, everyone that is thinking about the flexibility markets, the problem is who invite the platform that really will sell the flexibility as a commodity. Where are those assets in the grid? And basically this is the questions that we help to answer, because in our model, DSO might have directly access to this knowledge, who is virtual assets in my portfolio of, for example, 3 million of the users. So we give the knowledge to the distributor that give them on the another level that they can directly bid on the platform, and it's not that important. Are we provider of the platform? From the business perspective is, but not from the technical. It can be existing platform. I just would like to say that it's possible that we will slightly change the role of the aggregators, yeah, because aggregators can use also our model, but if they will just simply call to the customer and act in the way as they're doing right now, it's possible that they will be moved from the market by the DSO or other entities that are using for finding let's say the customers that have flexibility. Basically, using big data, they will be much more efficient, and in a standard way, it not be possible to survive on the market in the long term.
Okay, which sort of takes me to the next question, which is around the revenue model. So can you walk us through that?
Revenue model, yeah?
Yeah.
Okay, so I mentioned that platform is not important from the perspective of the technical, but it's very important from the business model perspective. And we are working on the model that we will be able to provide to the DSOs. And in, let's say, best case scenario, we can share this knowledge for free. And we will deliver also the platform. And basically, we would like to get commission on the deals that will be made on those platforms.
The deals for any of the flexibility services that are provided through it. Right, okay. And where are you operating right now?
You mean where are we based? Yeah, locally?
Well, which markets are you currently analyzing, assessing?
Okay, so right now we are purely, but you know, we started to checking the Polish grid, and for us the natural step is the European Union, which because this is the key issue is the regulation, because DSO even could be further with the flexibility markets right now, but there is no regulations, and it will take 2 years. We have hand on it. So we made already first step, and our friend right now is in UK, in Telford, on the conference of distributor assets. So we are checking on other markets, because it's give us also, well, what I'm trying to say, in other parts of the world, maybe some things will be able to do faster than in the European Union. And we would like to also take this advantage from there.
Okay. Is there any questions in the room?
I think from CLP, thanks.
What is the data, Ivan from CLP, what is the minimum data resolution requirement of those smart meter data, I mean, yeah, that you need from
1
us?
hour. If you are asking about the granularity of the data, yeah, where are the meter? Yeah, it's 1 hour.
Yes, yes, yes. What is
1 hour?
1 hour, 1 hour.
Yeah, did I understood? Did I answer the question? Did I understood it correctly?
By using 1 hour low profile, like what is the accuracy? Any past project reference that you can achieve?
Yeah, okay. So we do not work below 95% of accuracy. But what we do, we learn our algorithms also based on the 15, even of the 15 seconds, 15 because first we check the devices that are on us. This is a long story, but first we checked very in detail different devices on the side of the industrials, and then we put it together, and then we combine it to the 1 hour granulations, and we can do it backwards. So from 1 hour granulation, we can quite good decompose it for the other devices that are. Yeah, sorry, we are out of time. I don't know.
Yeah, thank you very much, Bartosz. It was great.
Thank you. Thank you very much.
And we'll get back to you in the next couple of weeks. Thanks.
Thank you. Bye. Have a nice day.
You too, in Amsterdam.
Thank you. I don't know, shall I disconnect it now?
Yes, you have a button, I think blue or red, that pulls you out of this room and puts you back in the waiting room.
Okay, so it's on my side. Okay.
Yes.
Bottom right corner, Bartosz.
Bottom right corner. Bottom, right?
Mm-hmm. You have to stop sharing screen first.
Ah.
Okay,
go.
now
Hey,
I should
Dimer.
be there.
How you doing? Welcome.
Hi everybody.
Hi. Congratulations for making it so far in free Electrons. As you can see, you have a room full of 7 utilities, quite eager to listen to your pitch about VLabs and all it can do. You have 6 minutes, followed by 6 minutes Q&A. So if you're ready, you can set up and let's go.
All right. Up. I will share my screen. I hear a little echo, but I think that's.
We'll turn off the mic in just a little second.
All right, perfect.
Okay, it's coming up, and we can see it.
Perfect. All right. Let me know when I can start.
Go.
Okay, so high precision augmented reality for geospatial data. We develop an industrial grade augmented reality solution for surveying, construction, and maintenance. My name is Dimer, and I'm the co-founder of VLabs. So we started out in 2018. We're based in Geneva, Switzerland. We're now active in 6 countries, including Canada, Australia, and Germany. We have a team of 8 people. And we're supported by multiple organizations, including the European Space Agency and InnoSuisse, the Federal Bureau for Innovations. Furthermore, we're partners with Microsoft and Esri. So what is it that we do and why are we doing it? Well, before civil engineering works take place, a surveyor has to go out in the field and spray the location of underground grids on the street. This is not only very time-consuming and cumbersome, it's also prone to human errors. And these human errors often lead to damages to underground grids. There's also a much larger problem in general, and that's the lack of digitalization in the field in the construction sector. And augmented reality is a fantastic technology that helps you further digitize fieldwork. So what have we developed? We've integrated augmented reality glasses fully with GNSS RTK. GNSS RTK is a centimeter accurate type of GPS, which allows us to visualize geospatial data, data of underground cables and pipes, or 3D models, BIM data on construction sites, with centimeter accuracy in the field. Not only can we visualize that accuracy, we can also maintain this accuracy over very long distances, which means that you can walk along the construction site without losing accuracy. And that is something that most of our competitors cannot provide. So what can we do with our solution? We can visualize data, as I mentioned earlier, but we can also capture a lot of data from the field. For example, we can capture geo-coordinates of objects simply by looking at the asset. We can also take photos, videos, measure relative distances, etc. And that, combined with work instructions, allows us to guide operators in the field through installation and maintenance tasks. To give you an idea, the German railways, they are testing our solution to install these yellow beacons along the railway tracks. They need to install tens of thousands of these objects. And currently they need a surveyor to mark on the railway tracks where these things need to be installed, a contractor to install them, and a quality assurance person to verify whether the installation was done correctly. With our headset, you don't need a surveyor anymore because we can guide the operator to the exact location. And you don't need to send the quality assurance person anymore to the field either, because we can capture all the information during installation. So that saves the German railways millions of euros per year. Now, I wanted to highlight for you two major use cases that I think are useful for utilities. And one of them is simplifying surveying. When you put on our headset, surveying becomes really easy. You can see exactly where all the cables and pipes are located. You can mark easily where the cables and pipes are. You can guide operators. You can measure objects. So you don't need to send a surveyor to every site anymore. You can outsource that work to people who are already on that site. So you save a lot of time and money. And not only that, you also save CO2 emissions created by travel by avoiding having to send the surveyor to the field. So it also helps your climate goals to reduce CO2. Now, the second use case that I think is really interesting for you is guiding operators in the field. Utilities are currently investing billions of dollars in renewing their grids for the energy transition, etc. But there's in general a lack of technical people. With our headset on, you can guide operators in the field, and so you can send less qualified people to do the work while maintaining the quality, avoid costly errors, and fully digitizing and standardizing your work processes. So again, you increase your efficiencies and you have to send less people to the field, so you can reduce your CO2 impact. Now, we target utilities, construction, and railway companies all over the world. So for example, we work with Endeavour Energy in Australia, and we recently started working with Hydro-Québec in Canada. And for example, Berliner Wasserbetriebe in Germany. So it doesn't matter where you are, our solution can be used anywhere in the world. We have two options currently that we sell. We have a plug and play solution, which is basically you buy a headset and a software solution, software license. And this is mainly for the surveying part. And since we support all these industry standard data formats, it's basically a plug and play. So you can buy a solution today and start using it tomorrow. So it's really easy to integrate. If you want something more complex, for example, tailoring the solution to your work processes, then we'll take you through a pilot and implementation phase in which we tailor the solution to your work process, after which we will give you the tools to adapt it to any type of work process that you might need. This takes about 6 to 12 months, and you need to think of an investment between 100 to 200K. Myself, I am the co-founder of VLabs. I have 10 years of experience in the utility sector. I'm a physics engineer by background. My colleague, Michele Corina, he's a mechanical engineer from the EPFL here in Switzerland with a lot of experience in AR and VR. And we're supported by an international team of business and software developers. And our board members bring in a lot of financial and IT management skills also from the energy sector. So we understand the energy sector. So what we are asking, what we're looking for today is we're looking for industrial partners and customers that are interested in further digitizing their fieldwork through the use of our high precision augmented reality technology. So if you have any questions, we look forward to answer them right now. So thank you very much for your time.
Thank you, Dimmer. That was great. And yes, we do have some questions for you from CLP.
I'm Ivan from CLP team. First question is, can you describe more about how your solution can capture the 3D scanning 3D images of the on-site record? Is it by just using your headset would be good enough, or do you need any other hardware?
So thank you for your question. It depends on the accuracy that you need. So we can do two things. We can export the 3D scan created by the glasses themselves, or we can use photogrammetry. Take a lot of pictures of objects. You can walk along the objects and take a lot of pictures, and then through photogrammetry create a 3D model. So I hear a bit of echo. So it depends on the accuracy you need. So we offer 5 to 10 centimeters accuracy, and that's not always sufficient for construction, for example.
Let's say your centimeter accuracy, that level. What do you need? Is it your headset that you shown would be good enough?
Yeah, I mean,
those data?
Yes. Well, 5 to 10 centimeter accuracy. That's what you need to aim for.
Okay. And you also mentioned in your pitch deck about beam model that you also have capability to view different beam model on site. Am I right?
Yes.
Right. Yeah.
That's
If
correct.
we have some like generation time model, is there any kinds of limitation for your software to view any previous pilot projects that you have done before in terms of this beam model? Yeah.
Yes, so BIM models, no problem, as long as they're geolocated, right? Because we work with the GPS, and if they're geolocated, we can position them exactly at the right position. Just one thing that you need to keep in mind, I recently did a demo with a utility here, it works perfectly fine. Just keep in mind it's a mobile device, so if it becomes a really complex model, several hundreds of megabytes, you cannot run that on the headset. Okay, so it needs to be able to run on a headset, so a rather simple geometry.
Any special requirements on the beam models?
That's a very good question. It's hard to say. It really depends on the complexity. I give you an example. We visualize, for example, a BIM model of a railway. Works really well, but if you start modeling all the screws of the railway, then those screws become extremely difficult to render in the headset. So it's hard to say, right? Okay. The modeling can be rather simple, but those screws, they can become complicated for our headset to render.
My last question, and Andre. Any value-added service that, apart from viewing those beam models, any special features that your software would be capable to help us, for example, adding some more points, RT points, etc., by ourselves, that we actually add them after the beam model was built? Yeah.
Yes, so what we can do nowadays is visualize BIM models, and we can measure geo-coordinates. So if that answers your question, so you can walk around, you can measure geo-coordinates, you can take pictures with very accurate geo-coordinates, you can measure lines, surfaces, but that's all GIS data. So we measure GIS data or relative measurement. So you can combine that with data visualization, BIM visualization, and geo-coordinates measuring. I hope that answers.
Thank you.
Just moving to some questions online that we have from EDP. Probably starting with some hardware ones. Weight of the helmet, minimum communication bandwidth, and then impact of sunshine on the glasses.
So weight, 900 grams. So it's rather okay. Then bandwidth, we use 3G and 4G because we need the corrections from the base stations, GPS. And that is important to get these corrections sufficiently fast. So you need to aim for 3G, 4G. And then finally, your question for the sunshine. If you're already familiar with augmented reality, the cameras, they use hand tracking, and that's based on infrared. So there's a lot of sunshine. Tracking of the hands sometimes becomes a bit complicated, so we integrated voice commands. So you don't need your hands to operate our tool, so you can use your voice.
Okay. Yeah, that was one of the questions. Speech recognition is available.
Yes, and we keep it very simple. So we have one-word commands. For example, click, select, to make it really easy for people to use it.
Okay. Another question that we have here, can you see the datasheet of the underground infrastructures with the helmet provided by the GIS or other asset management system?
Sorry, I'm not sure if I understood.
Well, if the person that asked the question, if you also want to open your mic, but the question is, can you see the datasheet of the underground infrastructure with the helmet provided by the GIS or asset management system?
Yeah, yes. So, for example, recordings with Esri, so we can connect directly to your, if you use ArcGIS from Esri, for example, we can connect directly to your database and download the data around you. So there's no manual preparation, and we can visualize all the attributes connected to that data.
Okay, cool. Thank you. And then I think we have one comment from Daniel from Eon. Could we please see documentation on past projects to get a better idea of the look and feel? So I can imagine that then you can share something afterwards.
Yes, absolutely. I was too short, 6 minutes, but I'll be happy to share data with you.
Okay, cool.
Awesome.
Thank you.
Thank you very much. Perfect. Thanks everybody and we'll get back to you in the next couple of weeks.
Okay, thank you so much for your time. Have a great day.
Thank you. You too. It was perfect Swiss timing, exactly. No, one more. Alberto. Hi, Alberto.
Hi.
Welcome. So congratulations for making it this far. And you have here, very expectantly, a room full of utilities waiting for your pitch. It's a 6 minutes pitch, followed by 6-minute Q&A. So if you are ready, you can set up and go. It's coming up. Yes, we can see it.
Okay, wonderful.
Go ahead.
So I am Alberto Sticca, CEO of Silla Industries. Good morning, everybody. Today I'm going to pitch you Energy Hub 139, a new product in development by our team in Silla Industries. Energy storage is a must for present homes, and Silla solution combines storage with solar system and bidirectional EV charging. Ongoing climate changes make management and distribution of energy challenging, and extreme events create problems due to blackout in increasingly larger areas, even to people not directly affected by the events. The change from fossil to renewable energy makes the latter cost increasingly more affordable, next to continuous rising costs of fossil energy. So, if you want to build or renovate your home to make it energy efficient, a best solution combined with an electric vehicle allows the best level of efficiency. And a typical battery energy storage system installation requires too many different elements, often from different brands. A solar inverter, a charger inverter, a storage system, a management system, a UPS functionality, and a router and network gateway for each one of these devices. So typically, you will need a lot of space, as in these pictures. And obtaining the best energy efficiency is often more difficult than it seems. Different devices must communicate and act in a coordinated manner with respect to dynamic consumption and mobility needs over time. So, Silla Energy Hub 139 integrates in a single case the features to manage energy distribution in a modern home. And so we are trying to integrate all the features of the different devices seen above. I don't know if you can see it, but here, what you see next to me is our proof of concept of the product Energy Hub 149, and actually in TRL 3. And the pre-series version will certainly be a little smaller. Above, we have a display with all the useful information. And here on the side, we have the charger part for the vehicle. The AC-DC conversion modules and the control electronics are housed in the central part, while the battery pack is housed in the lower part. So Energy Hub 149 has many top use cases. It can manage connectivity across the whole house, and it can manage a blackout event to maximize the autonomy of your house. It can be installed in the safest possible position thanks to its tethered connector to the car, and it will rationalize and save a lot of space thanks to its modern design when there is typically none available in the garage. It will set the electric vehicle to charge only with power from solar or storage or another electric vehicle, and you can use the electric vehicle to power your house when it's out of sun or storage power. Finally, it will maximize the efficiency between power consumption and multiple sources of production and storage. Our pilot proposal for free electrons regards one of the main and fundamental features of Energy Hub 149, which is the blackout management. In a blackout event, the 149 will take energy from the solar system, the electric vehicle battery, and the internal storage, and will restore the connection to the grid once the service is restored, is back again. Our approach to product development is about scalability of the software installed on a future-proof hardware that can be updated remotely without any modification to the installation. And about the development of this particular feature, we are facing some critical factor. We have an extreme need of different and realistic environments for test this kind of product on different markets. And we face a lack of relevant environments due to Italian incredibly outdated laws compared to other European countries also. So I can't move the slide. Okay. We are actually scaling up our production of AC chargers solution, which is the product line we are born with 2 years ago. And we have recently tested our modules for AC/DC bidirectional conversion, successfully performing a vehicle-to-vehicle charge and discharge cycle with a Tesla, a Hyundai, and Renault. And the pilot that we are proposing to free electrons is part of the transitional activities between TRL5 and TRL7 of the development of 149. And they are scheduled, these activities are scheduled for the end of 2023 and the early months of 2024. Our company plans investment in new product lines for over 6 million euro in the next 2 years. And the development of Energy Hub 149 project accounts for 60% of this budget. And the team of 6 people is already working on it. For the pilot estimated budget, we estimate around 585,000 euros. So we are born in 2021, and Silla Industries design, develop, and produce in-house hardware and software technologies for integrated energy conversion, storage, and EV charging. We are already present on the Italian market with a line of AC charger, which has generated turnover for over 7 million in the past 2 years. We are actually a team of 40 people, and we have an actual production capacity of 500 pieces per week.
Ok, grazie Alberto.
Yeah.
Abbiamo delle domande per te. We have some questions.
Okay.
Go ahead.
Thank you very much for this very good presentation, Sylvain Labonté from Hydro Quebec. So could you just again summarize what you would need for a pilot, basically? So you would need, battery, PV installed already. So could you, say a few more words on this?
The product is going to be developed first for European market because it's the closest to us. And we need a lot of knowledge about other regulation outside Europe, and also a lot of opportunity for a realistic test environment. So yeah, use cases where we can test these features. Also, when we talk to an utility, we get a lot of feedback of potential functionality that the product could also implement. So this is the right moment to talk about that.
Okay. Is your technology patented?
In the Energy Hub 149, there is one patent involved, which is a specific system to control external storage devices, because 149 can be installed also in existing systems where you already have a storage unit installed. And in that case, we developed and patented an hardware that will control external units.
Okay, thank you. I'm just reading the questions here from my colleagues. What is different in your product? You know, what is different from other similar products? You know, what's the difference?
Well, I cannot say about USA for sure, but from one of the latest fair here in Europe, I've never seen a device that aims to integrate all of these elements. You may see a storage unit with its own inverter. You may see some particular smart inverter for the solar implant, or a particular smart charger for the electric vehicle, but I've never seen such an ambitious project. And the goal is to make one product instead of many, which has a lower cost than the sum of the other, and a lot of better quality. Because when you have so many different devices, you have a theoretical efficiency that you can never reach, because different brands, different devices have a lot of issues in talking to each other and working to maximize the efficiency of the user.
Okay, thank you. You mentioned that you were focusing on the European market. So what would it need basically to adapt your product for North America?
We have a generic acknowledgement of USA and Canada regulations. So one part of the budget would be for sure on a market analysis on a regulation point of view. Also, it would need a partial review of the electronics. So that's a part to be developed only for that kind of market. Also, for experience, I know that if you want to successfully sell and distribute a product in the USA, you need to start with a commercial partnership that give you some presence locally presence in the market. And we actually don't have a partnership outside of Europe.
Okay, thank you.
Anybody else? Yeah. Okay, Alberto, thank you again. This was great.
You're welcome.
All right. Grazie mille. In 2 weeks, we'll get back to you. Good luck.
Thanks.
Thanks.
Bye-bye.
Arrivederci. Ciao, ciao. Great. Second batch. Well done. So halfway through the day. Who was online. Hope you enjoyed it. See you later.
the European market.
We don't have partnership.
In 2 weeks, we'll get back to you. Good luck.
Thanks.
Thanks.
Bye-bye.
Arrivederci. Ciao, ciao. Great. Second batch, well done. So halfway through the day.
Recording stopped.